We have 40 minutes of tour de force within the IoT and cloud area. So just to begin with, my name is Jakob Appel, and I'm the managing partner of Glaze here in Denmark. And virtually by my side, I have Fredrik Svensson, that is CTO and co-founding partner in Sweden, and also responsible for the Swedish operation. And also virtually by my side, I have Michael Rønde, who is the product owner of Beacon Tower and also a partner in Glaze. And just some information about how the webinar is going to be conducted. So we will take questions in the end. So please write down your questions or remember them otherwise, and then we will try to answer them in the end. And we will send the presentation, the slides afterwards, and we will also record this webinar and send the link afterwards. All right, with that being said, we will go straight into it. And we will begin with a short presentation of Glaze. Glaze is the company who has developed Beacon Tower, and Beacon Tower is, of course, the subject of today. But just to summarize what Glaze is as a company, we are a company that is specialized within IoT projects and has been that for the last 6 years. And we have two business areas. The first business area is development of customized IoT cloud projects. And it's based on these many projects that we have done over the last 4 years that we have developed our second business area called Beacon Tower, where we have developed our own Azure-based IoT cloud platform. And that is, of course, as I said, the order of the day. So that is just to get any misunderstandings about names and stuff like that out of the way. So we will move on to Beacon Tower. And before we delve more into the details, let's just briefly summarize the general characteristics of Beacon Tower. So Beacon Tower is an IoT cloud platform, and the whole idea is that it lets you and your organization focus on the business value. So we supply a powerful platform for streaming IoT data so that you can focus on the business value and on the structured data, so you don't have to do the plumbing of this infrastructure yourself. And it also lets you have your own data. So we don't replicate the data to our place. Everything is owned by you. All the data belongs to you, because the Beacon Tower platform can, if you wish to, be dedicated to your Azure environment and in your Azure subscription, so that all data is within your organization and you control the whole platform and it runs as a single instance for you. And that also means that you have implementation flexibility, which again means that if you want to further develop, integrate it to other systems, or make some other changes to the whole platform, that is possible, because you don't have to take into account what a lot of other users are doing. We will, of course, update and maintain the core functionality of Beacon Tower, but as long as you use the APIs, everything is flexible. And the last general characteristic is it's powerful and nimble, meaning that you don't have to ditch the PoC on Beacon Tower when you wish to do it enterprise scale. And that is one of the other things that we have seen during the last years, that what tends to be the way to do it is you build a PoC and then you start all over again when you want to do it enterprise scale. And that is not the way it should be done with Beacon Tower. In that way, by using Beacon Tower, you can actually leverage the PoC architecture and the whole development and the whole investment that you have done in that area. So that is the general characteristics. Let's move on. And the way that we are going to do this webinar today is we are going to show you a PoC on steroids. So we are going to do a PoC in like 20-25 minutes, and you will see some of the characteristics and some of the ways to work within Beacon Tower. And one of the ways to work with Beacon Tower is to set up an Beacon Tower instance in Azure. And to do that, I have my colleague, Fredrik Svensson, to instantiate an instance. So please take it away, Fredrik.
Thank you. Yes, so we will set up an Azure instance with infrastructure as code. And we do this, I mean, both to speed and deterministics. So by using speed or by using infrastructure as code, we can very quickly set up a lot of PoC services and other resources in Azure. And we do this the same every time. And this, of course, increases the from concept to PoC. It also makes it much faster to do multiple environments. For example, if you want to have a dev environment, a test, and a production environment, or if you want to do load testing. And we, of course, also know that if we do it like this, we can add new features to all our services in a very efficient manner. So we will set up an infrastructure as code here now, and we will start. We will start with an empty Azure subscription. There is nothing into it. And we will deploy a beacon tower into this Azure subscription, and it will land into this web page here sooner or later. So we do this by configuring a number of parameters that we need to make sure that the instance is on the correct scale that you want. If it is a small PoC, you have a smaller or less powerful instance, and you can increase that. And this is can of course be increased during the flow and lifetime of an instance. So you configure this, and after you configure that, you will plan to set this up. And we use a tool called Terraform, where we have programmed how the infrastructure should be set up. So we set it up, we start to plan, and Terraform goes to the Azure instance, communicates with what resources exists and how it should be, and comes back with a plan. And this plan, it will tell us that there are 95 resources that needs to be added. No changes and no destroy, which of course is perfect because there is nothing in it. So we agree that this is okay, and we apply this plan. So now Terraform takes and makes sure that everything is configured in the correct way and in the correct order as well. So while this is working, let's head back to Jacob.
I will just briefly introduce the general scenario of the IoT space. So when you're thinking of doing an IoT project and maybe even doing your own IoT platform, this is the scenario that you look into. So either you're doing smart production scenarios where you have a lot of OT automation systems already installed, need to pull out the data, make it available in the cloud, or you have industrial connected products that you need to condition monitor and get data out from and consolidate in the cloud. So then you need to make a whole cloud platform where you maybe also will have to have edge functionality, but you will definitely need real-time processing in the cloud. You will need some sort of asset digitization where you can model and structure and consolidate the data from the different devices. And you need to save the data in a format that you want it to be in. You also need to make it available, flexible, and open so that you could do AI and analytics projects in the future. And also so that you can integrate to other applications inside your organization or even share it externally with other stakeholders and integrate to that. So that is quite a hard problem. And if you look at it in a more business-oriented way, then our experiences at least is that in order to do the whole fundamental infrastructure and set it all up, that gives you limited business value. So that is the black curve here. And the effort, though, is not limited. It is quite high, actually, to establish this. There's a lot of technology challenges. There's a lot of investment and business case challenges, and a lot of organizational challenges in order to have the right competences inside or externally. So there's a lot of effort to gain this limited business value. And as you move on and integrate it more and more in your business, the business value will, of course, and hopefully rise. And later, it will actually, of course, have a very positive impact on your business. But we have a business case challenge in the beginning. And the reason for this is you need to establish a lot of functionality that is not giving you direct business value. I will not delve into the different dimensions in this presentation. You will get the slides afterwards, so you can delve into it if you want to. If we then see how we solve this business case challenge in Beacon Tower, we'll try to simplify it here with this box, which is the main areas that Beacon Tower encompasses. So in Beacon Tower, you get a scalable and flexible architecture that we can deploy at your Azure environment, and it encompasses an Azure IoT Edge framework. We have a real-time processing unit that is very, very powerful and can compute and can handle many, many messages, many thousand messages per second, and put them into that asset digitization model layer that you want it to be in. And this is something that Michael is going to talk a lot more about. And we save the data in all sorts of different databases, and everything is then accessible via APIs from the outside, either in your organization or externally also, so that you can build on top of this platform that we maintain and that we update. So that is the whole idea. And we can, of course, maintain this setup in our own Azure subscription and in our Azure environment, where we then call it a software as a service, or in your Azure environment, where we call it an integration platform as a service. And this results in another business case, actually, of course. And it means that the cost is straightforward, it's much more predictable, and it's much lower, and you get much more business value in the early phases. And it's also much more linear when you move forward. And if I should just sum up some more characteristics about Beacon Tower, then it is, as I've said, possible to deliver it as a software as a service, where we take care of the whole application, or as this iPaaS, integration platform as a service, in your Azure instance. And we can do this at any time, so that you can branch out of your software as a service or SaaS subscription, and then you could branch it out to your own Azure instance if you want to begin with a more limited scope. And we have our own user interface where we use our own templates, and you can use those, and that is what Michael is going to show you, or you can use your own and develop your own interfaces and applications and ways to interact with the platform. So what you're going to see is more or less as a third-party application that connects to the platform. That is the way that our user interface is made. And it also gives you complete implementation flexibility, as you can decide whether you want to move on internally with internal resources, or you want to move on with third-party resources as well. So you have a lot of flexibility in this kind of way to work with our platform and IoT data in general. So with that being said, I will pass the word to you, Michael.
Thank you, Jacob. All right, let me quickly share my screen here. Before we move on into the actual demo, I want to take a bit of a time looking at this almost architectural diagram. It's quite high level. So a bit to understand what we mean when we talk about an IoT platform, and it will help you a bit to understand the steps we go through later. So this is a very common view of IT platforms. You probably see that most of them would say that they have the same components. To the left, we have different data sources. It can be devices, edge devices. It can be device clouds or other sources of data that you want the platform to manage. All this goes through a cloud gateway, and for us is the Azure IoT Hub being used. And then that is going into what we call the distributed real-time processing pipeline. And what that does is that it manages all telemetry and all data coming in, and then it forwards that to the right places. One is to storage, but also it applies rules and alarms, and also it does any transformations to that to the data. For example, if you want to combine two signals into one, or you want to do an average or things like that. So this is the most like resource intensive part of the solution. Then we have parts dealing with devices and assets, and I'll get into a bit what that is. And this is, for example, to be able to manage, configure devices, to update them and do such things, but also to manage the more assets and organize them and structure the view you have of your devices, and also the access management of that. All of these components in here are microservices or PoC components, and that means that all of these speak with each other through APIs, and all these APIs are also available to customers, meaning that you can pretty much hijack or put in data anywhere and or get data out anywhere, meaning you can integrate any part of this to your existing systems, like for example to push in devices from your ERP system or something like that. And that also gives us this right part, which is usually where you have the business logic and applications and data analytics and so on, which, I mean, we can build or someone else can build it. It doesn't, I mean, that is totally flexible. And as Jacob mentioned, the UI you're going to see today is actually also built like this, meaning that we have a UI, you can replace that with your own, you can make an app, you can use both, or you can integrate it into your existing portals, whatever is I mean, works best to support your business. So I do hope that let's see here if everything is set up. So this is the Azure subscription that that Frederick initiated. So if I reload this, I'm hoping I'm going to see a lot more resources in here. Yes, so it seems hopefully okay. And then we're going to jump straight into it, and let's see if this also loads the instance itself. Right, perfect. So far, so good. So what we're going to do today is we're going to show a very quite simple demo, but we're going to do it in 20 minutes. So this is a demo of how you can, if you have a device that is IoT, Azure IoT Hub enabled, Azure IoT enabled, meaning, which doesn't mean that much. It means that it can support a standardized MQTT protocol of sending data towards, I mean, to the IoT Hub. Then you have a device that's ready to be used with Beacon Tower. And what we're going to see is the steps necessary to be able to get those first devices in and reporting data in the system. And for that, we're going to use an example case. This could be anything really, but just to have something more tangible to use. So we're going to have this wave power, converter, which is a wave power plant. We're going to connect a couple of devices. These have 2 data points. We'll keep it simple for now. They transmit data sensor values every 5 seconds. So the first part we need to do is we need to create a model. So asset models in Beacon Tower, well, actually, in a lot of these are used in different ways in most IT platforms, but asset models are used to describe your devices, because really the data a device sends doesn't contain a lot of information. It contains a key and a value. So it doesn't tell anything about what type of data it is, what it should be, is it or what other types of data there is. So the asset model is used to describe it. So we know how it works, what we can do with it, and what we can expect from it. And it also allows us to actually get some benefits from it, because we understand the data coming in. So if we jump over to Beacon Tower here, and this instance here that we set up contains a bit more data than you would see in your own instance, because this contains some test data that we set up to be able to work with it. We have 2 parts of the menu interface here. The top part is for normal users. The bottom part is for admins. You'll see both here as we go through it. So we're going to start with a model. This I'm going to just put in some, so we're going to call it a wave energy converter. That's an abbreviation we're going to use quite a lot. And if you also see that there's a lot of pre-filled in data here, if I enter it, that's just because this autofill in Chrome. It's because I've done this a lot of times. We're going to put a version. I'll get back to you a bit on how we use that. And then we need to create telemetry. I will only put in 2 basic telemetry values: wave height, which is a double, has a display name. It has a semantic type of distance, so we can use meters, and we save it. And we add another one, which is kilowatt generation, so actually the power being generated, and it's also a double. And we have a semantic type of power and kilowatt. All right. So that's pretty much it. You have a lot of other things you can do here. If you have more telemetry, if you have properties or commands, and if you have edge devices, there are more things to do here. But this is how you create one of these models. So we save it, and then we need to promote it. And what happens when we promote it is that we actually lock all the data in it, because once a model is used to, create asset instances and actual devices, we can't really change it, because that's going to lead to a lot of issues along the way if we start changing telemetry after a model is created. So if you want to do a new version of the model, you would do a new version with a different version number, and then you would migrate your devices to that version instead. So let's promote that. That seems to work. All right. So that is the model. Now we created that, and that's usually the most time-consuming part, because there's usually more telemetry values than this, of course. So the next part is that we're going to create assets, and the reason we don't call it devices is because their assets doesn't need to be a direct physical one-to-one representation of a physical device. In the most simple scenario, it is, and it's going to be in this demo here, where the asset directly shows what the device actually sends. But you can use assets, logical assets, in more powerful ways, and usually that is because you want to represent your reality in a better way than maybe it's done by looking at the physical devices. For example, if you have 10 machines somewhere, all where you gather data from them and you send that in through one gateway. So one gateway has maybe 100 telemetry values, which is true, but it doesn't make much sense, because you actually care about your 10 machines. And what you then can do is that you do bring in the gateway, but you also create these 10 logical devices representing the machines, and those machines only then have a subset of these telemetry values from the gateway on them. So that's a better representation of your reality. And there's also the other way around, where you can combine simple assets into more complex ones. For example, if you have 10 machines on a factory floor, you can combine those 10 assets into another asset, logical asset, which is then for example, a factory line, and then you can combine a couple of factory lines into a factory floor, and so on. So you can work this is quite a powerful tool, especially if devices aren't that straightforward. So this is the next step. Then we're going to create assets, and we do that in the admin part under assets. And I'm going to create a new one. So we're just going to call it vecnull01. We're going to choose the model we just created. We're going to give it a nice display name. And then we need to choose that this is actually not only a logical device, but it also connects directly to a physical device. So we need to also enter a physical ID. That's really all to creating a device. When I create this, I get a connection string directly. This connection string is the only thing actually necessary to have a device connect to Beacon Tower and being able to transmit data. It contains two parts. It contains the host or the address it needs to connect to, but it also contains a security key. So that's what ensures that the communication is secured between the device and Beacon Tower. So what we're going to do now is that I will copy this connection string, and then we actually will go into assets to have a look at what we just created. So you see here, there's a wave height in kilowatt generation here, which are the ones the parameters we created before, and they are empty. So then we will go into let's see where there. So this is a little a device simulator. So I don't have any wave energy converters available right now, but so this is simulating a device that communicates exactly the same way with Beacon Tower that a device would. But it's a bit easier for us to control it. So we create a device here, and the only thing I really need here is that I need a connection string. And as soon as I create this one, it's going to start transmitting data. So you hopefully, if I set that up correctly, you're going to see that the data pops in here pretty much instantaneously. Yeah, and there it is. So now this device here, and I can pop it up here and put it on the side. This device here transmits data every 5 seconds to Beacon Tower. And we just for the demo's sake, I'm going to create one more asset just like it. We're going to call it number 2. We're going to do the same model and name and create a physical ID. And we have a connection string, and then we just create a new one. So it's not really harder than that. And then we have the second one also sending data. So to some extent, you can say that the proof of concept is up and running. We actually see that we get data in here. So if a device is ready, I mean, IoT Azure ready, I mean, it takes, minutes to set up. Of course, in a real world scenario, there's usually some configuration that needs to be done and things like that, but it doesn't take long to do. But we won't really stop there. We're going to show a couple of other concepts, even if we're going to keep it on quite a simple level still. So the next part, after we have assets, is that we want to organize them. And we do that in Beacon Tower by using trees, asset trees, and tree nodes. And these are used throughout the whole Beacon Tower in a lot of different ways. For example, you can have multiple trees, and you can have them. So they should be set up in a way that they support what you need to do at that moment, meaning that you can have different trees for different purposes. For example, you can have one tree that organizes your customers and your assets for that each customer owns, or you can have them set up for where the assets are located, geographically, or you can set them up for the status of the assets. So you have those that are installed, not installed, faulty, up and running, and so on. And it might depend on the role of the person using it or what you need to do. And we can also use these trees to control access. So for example, if you have a customer that you want to bring into Beacon Tower, you can set up a tree for them with their assets and provide them access only to that tree and nothing else. And while you can do very complex trees, we're going to keep this quite simple for depending on the time we have. So I'm going to create a new tree. I'm going to call it wave power converter tree just for simplicity's sake. There it is. So we have only a root node right now, and we're going to create a new one. I will just create one called PoC devices for this case, and in there I will create 2 nodes, one for the North Sea where we have 1 device, and for the Baltic Sea where we have another one. So this is very simple tree. It can be as complex as you'd like it. And the next part is that we want to link assets to it. So these are 2 assets we created. I'm gonna link number 1 into the Baltic Sea and number 2 into North Sea. So that's it. These are linked here now, and everyone with access to this tree can now also see these devices. I can put one asset in multiple places in the same tree or in different trees. So for example, I could do this if I would like. And that might be because the way you set up a tree means that an asset should be available in multiple places. And this is also something that could be API driven. So once it's created, it's put in the right place in the tree automatically by your CRM system, whatever sales system or whatever you're using. We're going to remove that one again. In here, we also link dashboards. And a dashboard in Beacon Tower is a description of how you want to see data. So it's panels and graphs and such that show a way that you wanna describe your data. But it doesn't contain any data itself. So when you create a dashboard, the same dashboard you could link to North Sea and you could link it to Baltic Sea. And one would pick data from the nodes in the assets in here, and the other one would pick data from the assets in here. And then you could have a different, totally different dashboard higher up that would create more of an overview, for example. So that gives a flexibility in how you work with the tree and what you want to see in different levels. You also, as is mentioned, we give access here. So I will, if I give access, simply save, and then they also have access, and they will find this tree and have access to it. And if I now would go into the user part of this, I would find this tree here with the devices like this. That was very briefly on trees. They are a very important part of Beacon Tower. You can do a lot more with them, but we'll stay there for now, I think. So I'm not really. I could show you how alarms works, but I'm gonna time-wise only speak about it a bit. So alarms are really a combination of a rule that is applied on telemetry, and then that results in an alarm. It could result in other things also, but in this case, it's an alarm. If I create a new alarm, actually a new rule, I can apply that in 2 different ways. I can apply it directly to a model like this, or I can apply it to specific assets. And if I can apply it to a model, for example, if you have one type of devices that always have the same threshold values, you can create one alarm, and any new asset that's created within that model will automatically have this alarm connected to it. Or if you have different threshold for different installations, or there's other unique data you need to take into consideration, you can of course also do this per asset or per a number of assets, customer-specific assets. In here, you just see quite a simple operator and variable, the 2 telemetry values that we added. This is based on a scripting language that can really do any kind of complicated rules, but at a UI level at the moment it's quite simple, and that will evolve over time as necessary. That is alarms. The final thing I want to touch briefly on is integrations, because usually, even if you can get this far, usually the business value comes from actually doing something with the data. Exporting things to a maintenance system, analyzing it in a data lake or whatever it is. So the design policy behind the Beacon Tower is always that it should be very easy and flexible to be able to take your data out in any way you like. This can be done in different ways. You can use all the APIs that we use to have this work. You can pull out the data there. we can set up like streaming. We can stream to other endpoints. If you have systems that can receive it, we can stream directly into those endpoints. But there's also, of course, other ways, like getting them into more standardized analytic programs. And if you do work with Power BI, that comes out of the box as we are using time series insights as our time series database in Beacon Tower. Time series insights. So in Beacon Tower we have. Let me just see if I can go back to our assets we just created. So we have some basic charting functionality here. There's not a lot of data here because the device hasn't been living that long. We have basic charting functionality where you can explore data and compare them and so on. You can also use the TSI Explorer, which has some benefits to it. Or you can export the data to another system. And if you do want to use Power BI, you have a shortcut out of the box here with TSI Explorer, as you here can create Power BI queries just you just use TSI and you create a query. And if you import that into Power BI, you can work with the data directly. If you do want to do more complex analytics, either with another system or with Power BI, we would probably want to create a connector for that, so we can provide more data other than just raw telemetry data. Or someone else can create that also, as the APIs are available. So that is pretty much it from a proof of concept point of view. We usually say that we have a proof of concept process that takes 2 weeks. As you see, it doesn't take 2 weeks and actually work in Beacon Tower. This usually contains more of understanding the products, the devices, setting those up, maybe seeing if we can make them a bit more efficient in the way how they communicate, so they are more cost efficient in Azure. And also setting things up maybe in your Azure tenant or somewhere else. But the actual work to do so in Beacon Tower is, as you see, it takes an hour or so. And usually, even if we say 2 weeks, sometimes if everything is well prepared, it can even go quicker than that. So that's it. I have no idea if I managed to do a PoC in 20 minutes or if it took more, but here we are. So Jacob, anything you want to add?
I think it took 25 minutes, Michael, just to add on that.
All right, I'll need to improve.
Which I think is still acceptable for many organizations. Can you switch slide? So that was what I called in the beginning a tour de force within IoT cloud development and PoCs. And of course, we can delve much more into your specific requirements if you wish to. So please let us know and take contact. And also, if you have any questions, now would be the time to raise your hand virtually in Teams, and we will try to answer it. Oh, there's a guy. Carsten, let me see if I can allow mic. Now you should allow. The mic is allowed, and then you should unmute yourself, Carsten.
Okay, can you hear me?
Yes.
Okay, good. So, okay, first off, thank you for a very nice presentation. So my question is, if we have an IoT edge device, maybe a hardware delivered by you, what is the possibilities of integration towards the devices? Do we have possibility to put our own proprietary code onto this device, or do we have to be in the limitations of some framework or some platform? How you give us some info how to integrate device data into this IoT edge device? That's the question.
Should I take that, perhaps, Jacob?
Yep.
So yep, if we run it as an IoT edge device as we speak, it as an Azure IoT Edge device, then it runs containers. So if you have proprietary data, it is perfectly fine if it is wrapped into a container. We can just deploy the containers down to that one. If you want a beacon tower to communicate with it, I mean, it needs to send data that we understand, but normally it just comes up as JSON strings. So you model the data as Michael did to match the names that you have, and then it is working. So
just to be clear, I can create some sort of mediator container and deploy that onto your device.
Yes.
Okay.
So we don't really have our devices in the sense of that we have specific devices. We are device agnostic in that way. We can supply the devices that work with this, but more or less the only thing it requires is that it has a connector to the Azure IoT Hub. Then whatever is behind that in the other containers can be your proprietary code. You can work with it yourself. I mean, you don't even need our device to do it, but of course we can help you with that if necessary.
Yeah, okay, yeah. So I could have a direct access from my own device to your or to the Azure hub. Yeah.
This is the most standard connection there is. It's only like Microsoft's IT Azure standard. There are SDKs for that. There's no other. I mean, we don't have any proprietary data code in the device itself.
Good. Yeah, I think that answers my question. Thank you.
Yep.